In this event, we'll be exploring service mesh. We'll see why service mesh has gained so much momentum in recent years, and we'll discover how you may go about implementing a service mesh architecture into your own stack. But first off, what exactly is service mesh, and what's with all the hype around it? Well, to understand service mesh, one must first turn to the rise of microservices. Microservices are a useful style for development, but as a microservice ecosystem expands, you can quickly run into issues around deployment and scalability, among other things. So containers and container orchestrators like Kubernetes solved some of these issues by packaging services with their own runtimes, executing containers, and mapping them to machines. However, there was still a gap in a key operational logic, managing inter-service communication. So this is one thing that service mesh aims to do really well. And interest in a common networking framework has increased significantly in recent years. And in a recent article, I actually reviewed 9 service meshes on the market. And since then, even more have been released. There's also been more efforts around Envoy, WebAssembly, SMI, and other initiatives that could potentially affect all service meshes. Today, we'll get a background on Istio, one of the most adopted meshes out there. And as you can see, here's a basic architectural diagram of Istio. Istio is fundamentally a control plane and a data plane with sidecar Envoy-based proxies to handle traffic and apply actions on individual services. So that's today's theme in a nutshell, but I think it's time that I hand the reins to our experts to dive deeper. And today I'm very excited to be hosting 2 service mesh experts. We've brought in Lin Sun and Idit Levine. Lin will be giving us a framework to help understand Istio, while Idit will provide a sense of where the service mesh landscape is heading. We'll be doing back-to-back talks today, followed by a Q&A session. So if you're watching live, please type in your questions as they come up, and we'll get to everything at the end. So first up, I'm very happy to introduce Lin Sun. Lin has been working on container and cloud native since 2014, from Docker to Kubernetes to service mesh. She is currently an Istio maintainer, a member of the Istio steering committee and technical oversight committee. She is an IBM master inventor, holding 150 plus patents issued with the US Patent Office. So Lin and her team have spent numerous hours crafting the Istio Explained Getting Started with Service Mesh guidebook. Using this as inspiration, she'll be drilling into useful techniques for configuring, managing, and securing microservices using Istio. So thank you for joining us, Lin, and feel free to pull up your slides.
Okay, great. Thank you, Bill, for such a wonderful introduction. Let me start sharing. Can you see my screen?
Looks good, yeah. I see the PowerPoint.
Awesome.
And yeah, slide, yeah.
Okay, great. So today, I'm going to introduce a bunch of useful techniques to help you make sense of Istio service mesh. So I think Bill already gave me a wonderful introduction. The only thing I want to say is I recently wrote this book, Istio Explained, to help our readers to get started with service mesh. So managing microservices does not need to be complicated. As Bill said, microservice raise a bunch of challenges, right? How does the microservice connect and secure and observe each other, right? So service mesh is really coming in to help users, especially developers and operators, to solve that problem. So service mesh fundamentally is a programmable framework that allows you to observe, secure, and connect microservices. what Istio is fundamentally is the implementation of the service mesh. So Bill talked about 9 service mesh. His article that he compiled these. So Istio is one of the service mesh, probably the most popular service mesh out there, especially target for enterprise adoption. And fundamentally, Istio is solving the connect, secure, and observe microservice problem for microservices. Bill also talked about Istio architecture early. I want to quickly highlight that Istio community has done actually a lot of simplifications over the past year, that we actually consolidate our control plane into one single component. What Istio is doing interesting for, as part of the service mesh architecture, is as the service developer, you are not spending a lot of time to figure out how do you connect to the other services? How do you handle network failures? How do you do retries and config timeout? And do that in your code, you're actually relying on the sidecar proxy to do that work for you. So Istio provide interfaces through Istio API to allow you to easily configure the sidecar proxy to do the things you want to do, whether it's connect to your services, whether it's secure your services, so you don't have to code that logic in your service A or service B in this diagram. Istio fundamentally has control plane and data plane concept. So the control plane is the bottom layer. That's like the brain for configuring the sidecar proxies. And the data plane is the sidecar proxy that runs alongside with your service pod in the same pod namespace. Istio also have a gateway for controlling incoming and outgoing traffic. So this is something, especially the egress gateway with Kubernetes, you don't have control over your outgoing traffics on a layer 7 application layer perspective. You can control through maybe like network policy on IP and subnet basis, but that's not portable. So Istio provide ingress gateway and egress gateway, allow you to control inbound and outbound traffic on the application layer. So let's go to Istio techniques, hopefully to help you understanding Istio. So first we want to talk about install. The community really have done a lot of work to help you install Istio. So you can use Istio cuddle command. We have a default profile you can use. We also have like demo profile, depends on your needs. So the default profile is optimized for smaller production environment. We also recently added Helm support, so you can also use Helm if you're Helm shop to install Istio. And you can also upgrade Istio using Istio cuddle upgrade command, assuming you're moving from version to version. So when you upgrade, make sure you watch out for the warning and messages that actually gives you a lot of hints if any of your configuration are not super compatible from prior release to the current release. A lot of cloud actually offering managed Istio experience, like in our cloud, IBM Cloud, with one single click button, you can click on install Istio. It would actually install Istio for you within a single click. So with that, I'd like to introduce our application. This is also the application I use in the book to help you make sense of Istio. So within the application, we have 3 microservices all in the stock trader namespace. They are the trader service, portfolio service, and stock code service. We also have a data namespace to host the DB2 services, and stock code service also talk to external services, mainly to get the live stock price for a given symbol, a given company you have. So let's go ahead deploy this application. So within, without Istio or any service mesh, normally you would just deploy db2 stateful set in this data namespace we talk about. And for the other three services, trader, portfolio, and stock quote, we're going to deploy into stock trader namespace. So this is just plain Kubernetes. You can see at the end, you got the pods running, you got the services running, and notice here the pods says 1/1. So that means it's running each of the container for the service without any of the sidecars. Once the application is deployed, you can see you can access the application. Typically, people would do it either through Kubernetes Ingress or they expose load balancer service and access the application through the load balancer service. So let's first talk about how would you adopt service mesh in this simple example. So first of all, you may want to connect, secure your inbound traffic. So what we are going to do, assuming Istio is already installed, first of all, we want to configure the Istio Ingress gateway. So we talk about that controls the inbound traffic to a cloud load balancer. In this case, we did the IBM Cloud Load Balancer. So these are the different examples where we configure the communication, the secure communication between the cloud load balancer to Istio Ingress gateway. Now we're looking at how do we secure Ingress gateway configuration. The way to do that is through the gateway resource. So in this example, we want to use the trade credential to secure on HTTPS with port number 443 for the trader gateway. And then we also want to configure virtual service, right? Because it's not, when you hit that port number, you're going to hit the trade application because you might want that port number and the host name for other applications. So in this case, we would config /trader. When the URL is /trader, it would hit on the trader service on 9080. So now you can see we actually secure the inbound traffic now through a cloud provided host name. And from there, it goes to Istio Ingress gateway. And when the user hits /trader, we would route to our application. Notice here, we're not actually adding the services to the mesh. So let's talk about how you adding services to the mesh. There are commands like add to mesh. If your services are already running, you can run this command just to add the services to the mesh. You can also enable automatic sidecar injection on your namespace and then just restart your pod. So that would also allow the injection logic to kick in. So it would inject the Envoy sidecar to the services. So let's talk about what benefit are you actually gaining by injecting the services. You are actually getting observe the communications between your services, right? We talk about we have 3 microservices. So let's generate some load on the services. And if you bring up the Kayali dashboard, by the way, Kayali is Istio dashboard to allow you to visualize the interactions among your services. So then you will be able to see the interactions among your services, like the topology, the traffic flow in through the Istio Ingress gateway. So all that data, along with any error codes and connection failure, all that's available for you without any code change. So you get that simply by deploy the sidecar proxy with your microservices. Istio also have an add-on called Jaga. What Jaga does is allow you to see the trace spans for each of the requests. So this is powerful as for you to help you understanding where are the traces, where are the time spent for each of the traces, for every single request that's come in. So the way you click on a single request and be able to see all that data. And then you can determine, where's the bottleneck? Is there any errors that you need to pay attention? So all that data is immediately available for you. The next thing we see our user typically do is once they added the sidecar, they start to think, they want to secure communications among these microservices with service mesh. So Istio provides something called Permissive Mutual Tls, which is what designed to improve the onboarding experience. So what it means is the Envoy sidecar will attempt mutual TLS first, and if it fails, it will use plain text so the traffic can still go through. So this is helpful for your onboarding, but it doesn't help your security team when they said, I want every single traffic to be strictly mutual TLS. Pure authentication policy comes to the rescue. So as a secure owner of the mesh, you can set, I want this namespace to be strict mutual TLS enforced. Istio also allows user to easily dark launch traffic. So as you develop your microservices, you are going to need to have more than one versions someday as you make improvements. So in this case, we deploy a version 2 of the Trader application, and then we use virtual service resource from Istio to configure the traffic to say, what, I haven't tested my version 2. I want my 100% weight continue to route to the version 1 of the Trader service so that I could dark launch version 2 without impacting anybody. So as you can see, this is possible without you needing to make any deployment changes or any code changes for your Trader services. In this case, destination rule is really config client-side destination policies to the server side, where we are going to add, in this case, a version 1 subset and version 2 subset. You can also selectively route requests through virtual services. In this example, we're showing that you can say, I want to test version 2, but I'm not going to impact anybody, everybody. I want to only impact if the user are using Firefox. For anything else, I want to default back to version 1 of the Trader service. You can also use it to do canary testing. What if 80% wants to go to Trader version 1 and config 20% goes to Trader version 2? Once you gain confidence about Canary, you might want to also think about resilience tester, right? You want to see how it handles errors, how it handles retries. So you can also disable retries. I think by default, we do like 2 or 3 times retries automatically. So you could disable that and see how your code handles. So it still provides all these configuration for you without you needing to restart any of your deployment. So in this case, we're also configuring attempts of retries. And for every single attempt, what's the timeout between retries and the general timeout of retries. As you have developed microservices in the past, sometimes retries and timeout could be pretty tricky to get it right. And oftentimes you would have to modify code. So with Istio, you don't. You just apply a newer version of virtual services with your desired configuration. And then Istio control plane is going to read that information from Kubernetes and push it to the Envoy sidecar of your services and then take care of the configuration for you. You can also using Istio to inject errors to do kiosk testing. Like in this example, we are only introducing the delay when the user is JSON, right? So we're not impacting anybody else. We'll only introduce this fixed delay of 90 seconds when the user is JSON. We talk about outbound traffic. So Istio also allows users to easily onboarding by open up the outbound traffic for any traffic, but you can tighten that up as a user or admin of Istio. So the way you tighten it up is change the Istio config map to say, I want to have registry only. So only the external services that's been registered with Istio to say these are the allowed list to be allowed. And then in this example, we need to, the trader service needs to go to the IEX API to get the current trade stock price for a given stock symbol. So we opened up the connectivities from the trader namespace to this external host. And then through the service entry resource, we just apply, boom, we would be gaining access to it. I have to talk about debugging too, because not everything is going to go as smooth as what I just showed, right? So what I shown is through a lot of testing, a lot of things to get it working. So in Istio land, you always need to, because YAMLs are error prone, right? So you need to be able to analyze what might be going wrong with your resources. It's just an important skill as you adopt any service mesh. So in this example, as you can see, I have a gateway resources, which is going to be harder to figure out what might be wrong. So Istio Cuddle Analyze come to the rescue. It's one of the most useful command, in my opinion, out of Istio Cuddle, that it actually shows you can what is wrong. So the simple here for the TLS mode was not spelled correctly. So you can use Istio Cuddle to analyze the given namespace, a given file, that's like this example, or you can analyze a whole live cluster. Istio Cuddle Describe allows you to describe a given service or deployment and show you what are the information that Istio cares about. So this is also particularly useful as you onboarding your services and troubleshooting issues with Istio. Oftentimes you want to look at your proxy configuration to see if you get the right contents. Istio proxy config allows you to see like your route configuration, your endpoint configuration. So all that configuration is available for you. You can also check the proxy status, just making sure the proxy have the latest information from Istio control plane. So with that, we talk about how do you install Istio, how do you secure your edge services with Istio Ingress Gateway. We talk about how do you inject sidecar, how do you observe the connections among your microservices, how do you secure your communications among your services, how do you control traffics, how do you actually debugging issues with Istio Service Mesh. If you're interested in learning more about Istio, go to istio.io or read our book on getting started with Istio Service Mesh. That's all I have. Yeah, back to you, Bill.
Thank you, Lin. Yeah, great overview of Istio and some very useful commands to get right into the technical details of actually implementing it and configuring it, controlling traffic and security and more. That's fantastic. Yeah, this has opened up some questions from our viewers today, and we'll get back to that. We'll answer any unopened or unanswered question at the end of this next session. And so I'm going to bring up Idit Levine. I have a little introduction for you here, Idit. All right, here we go. Idit is the founder and CEO of Solo.io, a company that develops tools to help enterprises adopt and extend innovative cloud technologies alongside modernizing their existing IT. And prior to Solo.io, she was the CTO of the EMC Cloud Management Division and a member of the Global CTO Office. She has spent her career building all areas of cloud infrastructure and open source software in both startup and large enterprise companies, including Dynamic Ops, VMware, CloudSwitch, and Verizon. And in her talk, Service Mesh, Past, Present, and Future, Idit will describe the landscape to see how we got to Service Mesh, and we'll go beyond the network itself to envision what's possible once we abstract the network from the application. So yeah, looking forward to some more like larger overview of where Service Mesh stands in the ecosystem here. So yeah, take it away. Thanks for joining us.
Thank you so much, guys. So let me share real quick. And you'll show me in a second that everybody see my screen, correct?
Yeah, it looks good.
Yeah.
Awesome. Good. Thanks so much for the introduction, Bill. Really appreciate. And thanks, Lin, for an amazing overview. So what we will do here is that we'll start by basically basic. Maybe it will be a little bit overlap with what you heard, but I think it will be a little bit more in details. And then we can go, and kind of like understand what is the ecosystem, what's going on, which one you should use, and so on. So let's start first of all with why that is important. I think you guys know that, but I will talk about it a little bit more. So as you know, there was a huge shift from monolithic to microservices. Actually, the reason this shift wasn't related whatsoever to technology. The reason this shift is happening is because organization problem, right? If you have one big binary and everybody from your organization is basically contributing code to the same binary, it's really complex. Versus what Microservice is doing is basically giving you, basically distributed the application that way that each team will be able to own their own business logic. So this was a really good solution, and it will allow you to go faster and so on. But that's also mean that everything right now is going to happen on the network, right? Basically simple stuff that before you definitely did not need to take care of, right? Like how the pieces of the application is going to communicate in the same binary. Now it's different because it's different binaries, right? Same thing with observability, same thing with how do we make sure, and more problems here because suddenly, we solve one problem, but we introduce a bunch of few others. So basically, if you think about it, by this move, we make the network so important piece in your infrastructure, right? Because now everything is going on wire. So let's understand again, kind of like what is the challenges that it will achieve. So first of all is routing, right? Very simple. Now I need those two to communicate. They're distributed, which means that they are not the same binary. Somehow we need to make sure it work. That means that's going to go over the wire. The second thing, if they are communicating over the wire, we need to make sure that it's really, really secure because potentially there is some third party who can interject between and do a lot of mess. And the last one, because now we have a lot more copies of each of the microservices, potentially you have service A, you want to talk to service B, but there is a lot of replica of those services. And therefore what it means is that you don't really know when the request is coming. So, right, you have no visibility whatsoever. So, A is talking to B1 and B1 could talk to C2 and so on and so on. And you don't know what is actually from the request, what is the basically flow. And that's what creates you a problem. Like, for instance, how do you collect the log right now, right? They're basically spread all over around. It's definitely with different transactions. How do you make sense of it, right? So that's basically what Service Mesh is trying to solve, right? The first thing is routing, traffic control, and resilience. The second thing is security, and the thing that is focusing is root cert, MTLS, and policy. And observability-wise is going to collect the metrics and the logs and we'll try to make sense for them. So that's kind of like in the nutshell. Okay, so how does it going to happen today? Let's say that Service Mesh does not exist. So it's pretty simple, right? So A need to talk to B. But that basically means that you, the engineers, actually need to put a lot of operation code inside your microservices, right? So your application, your microservice is not only your business logic right now, right? It's also the operation of how those two can communicate it. And maybe you will need to attach some libraries for a lot of other reasons. And that's causing a problem because basically once the business logic is located together with the operation code, that means that every time that something changes in some library that you expose because of the operation, you will need to redeploy the microservices and create a new version, even though you didn't change whatsoever the business logic of your application. So that's creating a little bit of a problem. So that's exactly what Service Mesh is trying to do. In the nutshell, if I need to show one slide of saying what is Service Mesh, that's that slide, right? And what it's basically saying is that we abstract the network. We took everything that related to operation, we took it out of the business logic of the microservices, and we put them to the sidecar that you can, in a declaratory way, configure it. So you don't need to redeploy the business if you want to change something in the operation. So again, how is that going to work? I think they talked, Lin talked about it as well as Bill, so I'm not going to talk about it too much, but in the nutshell, we're putting basically a sidecar next to each of the microservices. The most common one will be Envoy, as you can see me putting it here, but in the nutshell, Linkerd has their own and so on, but in the nutshell, you could putting it here. And basically that's the gate to your microservices. So everything that is going between those microservices in and out is going to go through the sidecar. We'll be able to basically make a decision, right? Should he let it go? Should he not let it go? Does he want to append something, right? We will be able to basically do a lot of magic on the request button. So that's great. We have this, this microservice, this sidecar. That's great. But, Envoy or any other proxy is really, really powerful. There's a lot of stuff that it can do, but there is one more thing. It's actually pretty dumb, right? It will do what you tell him to do. It's very powerful, but it will never done it without you telling him. So someone need to tell him what to do. And that's exactly the control plane. So the data plane is the proxy itself. That's when the request is flying. And then there's the control plane that their job is basically feed the configuration right before runtime and basically make sure that when the request will come to Envoy, Envoy will know what to do, right? And that's basically what it is. The request is coming for me, let me go. The request is coming for someone else, do not let it go, right? Or something like that. So that's basically how it's working. This is something that is a very popular pattern. It's true for API gateway, it's true for service mesh. In the nutshell, very simple. You're putting in a data plan that it's pretty dumb, and you need to have a control plan that is that is smarter and basically can collect, for instance, data from your environment and know that one of your services is down and that you need to do something about that and so on. So that's basically what it is. Okay, so now basically this is what we did. We abstract the network. Okay, so that's great. And I think that Lin talked a lot about how to actually operate a mesh, which I think is great. And that's probably where I will talk about it right now because it makes a lot of sense, but we will skip that because that's already done. And we will talk instead of it about the challenges because, we should be true for the challenges. There is huge, everything is trade-off in life. There is huge advantage, but there's also some, drawback, and we need to talk about that. So service mesh is extremely accessible place. As I think Bill mentioned that before, there is so many, and to be fair, there are going to be more because that's what will happen. It's happened before that in the Kubernetes ecosystem when, microservice orchestration, there was a lot of, Mesosphere and Cloud Foundry and Docker Swarm and so on. And that same thing is going to happen here. And that's something that was very clear that that's what will happen. So what you can see, this is some of the service mesh that exists today in the market. And me, as Mr. Customer, has a lot of problem right now because how do I know which one to choose, right? I mean, what is the advantage? What is the disadvantages? Why should I choose one by the other? And how do I choose the one that is actually right for my use case? Because maybe my use case is extremely simple and I don't need the overhead of the others. So let's understand a little bit this, right? And as I said, the problem that people will have is that how do you know which one to use? So what we saw, at least not now it's actually a little bit clearer, but what we see a lot of our customers is basically started by exporting, right? Put a team to work on Linkerd and then a team to work on Istio and a team to work on Console Connect. And what happened is they spend all this time because it's extremely complex. It's not a simple piece, right? You need to learn those API. You need to define that there's problem, it's not simple. And in the nutshell, maybe they make a decision or they make a decision that it's too complex, right? That's two things that we saw in the beginning. Now it's different a little bit. And the thing that I think was the most nervousness for them is how do I make sure that I'm choosing the winning one? And until recently, it wasn't clear who is the winning one, right? There was a lot of reason why, there was kind of like a distributed ecosystem. So the biggest risk is that will happen. What happened to people who chose Mesosphere before? They chose Mesos, And then they needed to drop everything they did and move to Kubernetes because that's what the ecosystem decided on. So that's basically that. And for that, we introduced a product, I don't know, 2 years ago, right? Now, that is relatively extremely simple. We call it Superglue. And the idea was very simple. We said, don't worry about it. Let's just put an abstraction on top of it, right? And it doesn't really matter which meshes you're using, right? And I will explain why it's really important in the next slide. But in the nutshell, it's very important because even if you decided that Istio is the winning one and you're using it on-prem, I will argue that if you're using AWS and you want to use something that is natively, you most likely will want to use AppMesh. And the reason is because they're owning the hardware, and therefore they can do crazy stuff like bring, for instance, the Lambda to the mesh. When, with all the respect, if you're not on the hardware, you will not be able to do that, right? So there is a reason why you might want to use more than one service mesh. But one very important thing in this abstraction is to make it simpler. And this is Istio, this is very old one, this is 1.5, right? But it's showing the case, right? In the nutshell, Istio did something that is very important, and that's give a lot of power to the user, right? It's very important that they will be able to do a lot of stuff. But when you have a lot of stuff, then your API is extremely low level because you basically need to mimic the data plane control, basically Envoy, right? When Envoy is a complex thing. So you can see stuff in the API, like for instance, I don't know, Sidecar. And to me, Sidecar is implementation details. So the question, and maybe this is not the right name for this API, but in the nutshell, what I'm trying to say is that there is a lot of implementation detail in those API, and that's a very complex to learn. So what I try to do is to understand what is actually the feature that I'm giving to the customer. What do they want to do? Why do they taking service mesh? And try to simplify that way that people that doesn't want to understand Envoy to the gits and guts will still be able to use service mesh. And what I came is very simple. In the nutshell, you have a lot of services, right? Or workload, right? It can be a VM, it can be serverless function. But in the nutshell, you have a lot of them. And the only thing that service mesh is trying to do, right? The way you will act service mesh, if you will choose a source, right? Source of it, and it doesn't matter which type is this workflow from, you will be able to choose a destination. And again, doesn't care, right? And what you also want to do then is basically put policy on the pipe. So here's my source, here's my destination. I do not want them to talk to each other. Here's my source, here's my destination. I want them to talk to each other on if it's Idit. Or here's my source, my destination. I want a retry of 5, right? That's basically all you're defining here. Something very, very simple. Okay, so I mean, we'll talk about it really quick, but in the nutshell, we announced together something called Service Mesh Interface. The idea, it's basically was what we created with our vision, and Microsoft helped us push it with marketing. In the nutshell, that's a way to simplify service mesh, right? But that wasn't the real problem. The real problem was, that wasn't the only problem, right? The problem is more complex with this, because in the nutshells, you usually have more than one service instances of service mesh. And the reason is because you will have more than one cluster, right? So just an example for some of our customers, we have a customer that running everything from 50 cluster to 100 cluster. And now we have a new customer that running 1,000 cluster in production, all of them running instance of Istio, right? So now the question that I have for you, how do you manage something like that? How do you orchestrate it, right? Now everything that, think about what I'm saying here, everything that Lin did in her presentation on one cluster, now you need to do it on 1,000. How do you manage that? How do you make sure that you operated that? And that's what we see in the market. That's what we see from our customers, right? And as I said to you, it's a big organization. And by the way, you're all using them, you just don't know. And they're all using Istio in production, and they all actually need to orchestrate this thing. So what basically, and so that's number one. Number two, as I said, you have more than one cluster, you have at least two instances, right? Of same mesh like Istio, but potentially even different one. Like for instance, if you're going, as I said, to AWS, you might want to use AppMesh. If you're going to something like, for instance, Microsoft, you might want to use Open Service Mesh when it will be ready, right? And the question is, how do you do that, right? So basically, if you think about what I just described, what I want to do is that if I have a source and destination that are in different clusters, I still want it to work the same thing, the same way. I don't care how much instances of mesh I have behind the scene. I don't want it to, go to one of each and basically configure. I just want to make sure that it's configured well. So this is exactly what we basically did. It's something called Service Mesh Hub. It's an open source project. It's now called Glue Mesh, but it's an open source project. And basically, again, the idea is very, very simple. We want to make sure that, it's simple to use. It's dealing with multi-clusters, and it's giving you a lot of the simplicity behind the mesh. So it's an open source project, so go check it, but that's the idea, right? And it's bringing a concept, which I think is extremely important, which is virtual mesh. So the idea is, I want to know how to group meshes together, treat them as one virtual mesh, and basically make sure that it's still secure, that they will communicate. And that's exactly what Glue Mesh is, right? So again, it's open source, so go have fun. And another functionality that there is, and I will talk about it in a second, is the fact that if I have a lot of I have a source, I have a destination, I have a policy, that sounds really simple, but actually it's way more complex than that, right? Because you have a lot of source and you have a lot of destination. And now the question is, what's going on? If I'm looking at that specific service, right? I want to target which a policy actually apply on it. And again, that's something exactly that part of the thing that Glue Mesh, as I said to you, it's an open source project, so I really recommend you to go, but this looks something like that. It's extremely simple. You basically have here, for instance, I have, you register your cluster. So I have 2 cluster register here, and this is a live production, right? I have 2 cluster here, 2, I discover automatically Istio in each of them and open service mesh on them. And then basically I see everything that exists there. So if I will go right now to the meshes that I have, I found 2 meshes that I join as a virtual mesh, right? And I can see all the source, all the destination, and I can go and see which policies actually apply for it. I have all the source that I can see, and I can apply failover, something like failover a function. For instance, I want you to go to the same cluster, the same service that I want on the same cluster, but if it's failing for some reason, go to the failover in the other cluster, right? And that's some policy that you can see here. It's very simply defined. Everything is CRD based, so this is just a UI for fun, right? And you can basically, every policy that we discuss right now is be able from the source to destination, here's what the policy that I want. But the beautiful one is this, that behind the scene, the only thing that we're doing is basically translating to the actual mesh. And that's what you can see here. You can see here a lot of basically Istio configuration that created behind the scene that you can actually go ahead and do it. So again, open source, I really recommend you guys to look at this, but let's go real quick to the presentation and talk about why I'm excited about the future. Okay. So let's right now look at the future of service mesh, which I'm specifically extremely excited about it. And let's talk a little bit about extending the data plane. So we talked about that, right? It was pretty simple. But here's what you need to know. Envoy is very, very powerful. And it's so powerful because it's built in a very nice architecture that basically allows you to extend it. And this architecture basically built that way that when a request coming, it's going to something that's called filter chain. And you can control those filters. You can write your own custom code. And today, you need to do this because Envoy is a C++ async. You need to build it to actually write a C++ async filter and recompile Envoy, right? And we're doing it. We have an API gateway called Glue. This is what we know how to do very well, but that's extremely complex, right? So, actually Google came with this idea of basically, what if we will find a better solution? How can we allow other people to actually put some logic in the request path, logic like transformation, logic like metrics, that is very specifically for you? This is why it's not in the community, but you want to do this, and you don't want to understand, maybe C++, or maybe you don't want to know how to compile Envoy, which, trust me, is not fun, right? So basically, Google looked at the WebAssembly and said, this is a very interesting one. So what is WebAssembly? So WebAssembly is actually technology that comes for the browser world. It's not related whatsoever to the cloud. And the idea was, how can I give my customers the ability to run something that is faster than JavaScript, but they will be able to write code, but there is some functionality that is very important to me. For instance, because it's a browser base, I want to make sure that it's portable, because we have a browser everywhere today. We want to make sure that it's fast, right? And this is exactly example of what is the difference between JavaScript cursors to a WebAssembly. We want to make sure that you can run it in every language, because C++ is pretty complex and not everybody wanted to write that. And we want to make sure that it will be secure, because you definitely do not want to write something that will take your browser down. And that's exactly what WebAssembly is. But when we look at it, we said, this is interesting. What if we will be able to actually bring it to Envoy? And then let people basically dynamically extend the data plane. Now it's very interesting. And that's exactly what we worked on. So basically, Google was the leading of this initiative, took WebAssembly, brought it to Android. That's great. So now it's easy. But then I look at this, and this is a tweet from Solomon Hike, who is the founder of Docker. And he basically wrote that if WASM and WASI, which is the interface that you can extend and take it outside the web and basically bring it to something like Envoy, was existing in 2008, you will never build Docker. And then it's kind of like it means that there is a lot of similarity between the way Docker is Docker and basically a WebAssembly is built. So what you see here is the way that I did it in my head, right? I said, look, Linux container was there before, right? There were people that using it. Google was using it. Though the user experience was pretty bad. And then what Docker did, they basically make the user experience to make it all want to use it. And now I can use it. And my mother can do it. Not my mother, but someone can do it, right? Same thing I saw when I saw the technology. I think that, bring it to Envoy, it's an extremely complex problem. And we actually contribute in code there and help with this, but that's not enough. We need to make it something that you can use it. And that's why we created something called WebAssembly Hub. And the idea is exactly like Docker. It's something really, really simple that you can actually, from a command line, write wasm, we call it wasm build, wasm init. You choose the language of your choice. You click in, it's creating you all the project that you need. Now go put the business logic and then do build. Then you can do pull and push, and then you can do deploy in all those. So either in Glue or in Istio or in just vanilla Envoy for your debugging. So that's a very powerful, and that's going to change Envoy, because if you think about what Istio did, Istio basically abstract the network, or any service mesh is abstract the network. I think that's giving us so much stuff that we can do right now, right? Envision that, any platform like iPhone or Android that you can put right now apps, and basically who said that you can only talk about it, That's exactly the idea. So again, WASM is open source, WebAssembly Hub, it's out there, it's just free. You can use it and play with this. Again, it's everything that, if you know Docker is a very simple experience. And that's all I have. Hopefully it wasn't too much. I don't know if I'm good in time.
No, that's great. Thank you, Idit. Yeah, time is all good here. Yeah, well, it's so much to unpack between both of these presentations. I'm excited to dig into just some brief talk and maybe try to answer some of these questions from the Q&A that Lin or you, Idit, haven't already typed in. But yeah, I'm always excited to sit down with you, Idit, because it seems like there's always a new project on the horizon. You're seeing the scope of all of the whole marketplace, and
you should be stay tuned. There's way more.
I'm always trying to keep up. Always trying to keep up with you. First off, I noticed a question that could apply to both of you here. It's how we're approaching zero trust security and how that might work with Istio. So I thought we could start there. Maybe Lin?
Yes, sure. So basically the Envoy sidecar is handling the secure communication for your services. And it's not like we handle it in a super dumb way. We actually handle based on your configuration of Istio resources. So within Istio, there are authentication policy, and there's a user authentication. There's also peer authentication, which is the authentication on the transport layer where you configure mutual TLS. So in my slide, I only showed you how to do mutual TLS, strict mutual TLS configuration, but Istio does provide authentication policy and authorization policy. So you essentially, as the user of the mesh, which is like typically the service owner or security owner of the service mesh, you configure the Istio authentication or authorization policies, and then Istio is going to listen to you and then push the configuration to the Envoy sidecar and handle all that for you.
It seems like you mentioned in your slides, Lin, that there are some security defaults that might be a little bit open at first.
Yes.
You could remind our listeners of that, because it seems like that's kind of important.
Yeah, so we have Permissive Mutual Tls as the default installation comes in. So the goal is to allow you to inject the sidecar to the mesh and your services continue to function without disruption. Because sometimes when you start to enable like strict mutual TLS, you may see, you know, some of your connectivity are not going through, especially when you talk to external services or when you talk to stateful sets. Sometimes they have like quorum and leader election within the members of the cluster. That's when you see, you know, when you start to enable strict mutual TLS, things might fall apart. So we want to make sure, you know, your service continue to function first, and then you tighten up the security based on your business needs.
Yeah. I'd be curious to get your take, Idit. I mean, you're seeing multiple meshes here. You have a good take on the landscape. What do you feel are the meshes that are really adopting zero trust and doing it well? And can you be operating that from this control plane that you've kind of introduced with Glue Mesh?
So yeah, so to be fair, what we see, and I will be very blunt, that's what I'm doing. If in the previous years, we're working with Service Mesh for 2 years, we saw a lot of meshes like Istio, Linkerd, Console Connect. I will be totally blunt by saying that we mainly see Istio right now with all our customers. We have a lot of customers and a lot of people coming and asking for Service Mesh. I think that we don't see a lot, like open source people using Service Mesh. That's what, like Linkerd, that's what we see. But to be honest, that's what we see. We don't see them. We don't hear them anymore in accounts. With Console Connect, again, I don't think that we're hearing them as much. Definitely not hearing Kuma and the rest. So basically, it's mainly an Istio, and that's what people are asking, I will be honest. And again, good job, Lin. So in terms of management, listen, I mean, as I said, the idea is that if you think about what Lin said about what, like, Istio is giving us all this building block to build what you want in Zero Trust. But actually to do this, it's a huge configuration complexity. What we're trying to do in our level, which what we're calling a management plan. So there is like the data plan, the control plan, the management plan is basically make it as a one simple thing. I wanted this and boom, it's going to happen. And we will orchestrate it between all the meshes, make all the mesh just way, way simpler. And that's basically our approach. So the answer is yes, definitely you can do this. This is all the point with virtual mesh, right? You don't worry about it. Like, I mean, we will go behind the scene and do a lot of magic with the certificate and everything and make sure that everything is going to work. Yeah. And that's basically what we're doing. And I think, as I said to you, like we see a huge demand on this in the market. If this is like, we have one huge customers that has, for instance, it's, I can't name the name, but you know, a lot of SaaS huge product that everybody's using it, but think crazy amount. And basically each of them, they're basically grouping as a virtual mesh and there's follower and all this stuff. And then they're also doing the, you know, they wanted to talk between the virtual mesh. So there's a lot of very interesting use case, but in the nutshell, the idea is let's keep it damn simple. Let's also, you know, a lot of the stuff that I think is very important in Operation Istio, which is what we see, and this is something that we build in Glue Mesh, is, for instance, today, if I'm using virtual service, basically there is a lot of functionality out there. You can define traffic and you can define retries and you can define a lot of the stuff. A lot of the time, I don't want to have to give someone permission to do all of this. Like, for instance, this is just my application team. I really just want them to use retry. I do not definitely want them to be able to control any other services, but I also do not want them to actually be able to configure something like traffics, right? How is that going to work? So that's something that we build. We're basically taking all the Istio API and giving you the ability to slice and dice this the way you want with fine grain, and decided, for this team, application A, that owning service one, I want to give only retry, but I'm an SRE, I want everything, and I'm an admin, I want this. And basically we'll be able to group that. And I think that that's something that we see very, very valuable, even if you're using, by the way, one single service mesh, let alone if you're using a lot.
See, that was my thing. When you first introduced this idea of this agnostic control plane, sort of the marketplace as an abstraction layer, I was like, okay, well, if the market's just going to consolidate around a single mesh, is this really necessary? But it seems like, you know, with all your examples, it could still be helpful, even if you're only using Istio, just like thousands of these instances.
Right. Because
Okay.
I think that the scope of Istio is exactly what it should be. It's a service mesh, that's the scope. If we will try to build a lot of stuff on top of it, it's become even more complex. So I think that that's what we're trying to simplify there.
Yeah, balancing complexity and simplicity is always going to be difficult here, it sounds like, which kind of falls into my next question here. I'd be curious to get, we've heard Idit's take on WebAssembly and its use in the Envoy chain. I'd be curious to get Lin's take on that. You networking folks seem to want to just throw everything in here. We're introducing logging, metrics, transformation in this kind of sidechain ability you're describing. I'm worried that, are there downsides there? Are we increasing latency? Like, what are the repercussions of doing things this way?
Yeah, so, I'm also a huge believer of WebAssembly with the future of WebAssembly. I guess the main reason I didn't talk about WebAssembly today early on was the stability and maturity of WebAssembly within Istio today. It's not something, I would consider beta for our users. But WebAssembly plays a huge role within Istio service mesh and potentially any other service mesh out there, is because the customizations we've seen our user needs beyond the Istio API can provide. So in Istio, we have this thing called Envoy filter, which allows user to extend their Envoy beyond what Istio API can provide. So we're hoping WebAssembly would be a more standardized way to help us replace the needs for Envoy filters and help users to add customer code. So we're going to always see users do things on top of what Istio could not build, and we are not interested in standardized because Istio is more optimized for that 80-20 scenario. Our priority is going to be that 80% scenario, but there's always 10%, 20% users, they want their stuff that's in Envoy, but not in Istio API. So WebAssembly opens up a huge opportunity for that.
Yeah, that makes sense, offering the flexibility for that 20%.
Yeah.
Maybe I will add, because we are also, I think that one of the questions that you ask right now, which is very important, is it giving a latency? And the answer is yes, definitely. What we see is an increase in latency. It's very important to say, and to be fair, when we're giving this chain, it's always true, even before WebAssembly, right? If you're putting a lot of logic that Envoy need to do on those filters, it will take you more time. So be smart, you can go crazy. I will say that we are very excited to say that one of our biggest customers that you're all using, and you don't know that, is actually going right now to WASM in production on January, actually. So right now, and it's actually, we're working with them, and every problem that they have resolved and put it upstream for Envoy. So, it's a Glue customer, so, they're not using Istio, but I will say that we are running it in production very soon and tested like crazy that. So it's looking good. And as I said, you need to think about why you want to do it. The idea is, for instance, they didn't want to do the extra hop with the external auth. So it makes a lot of sense to them to build it into Envoy. I will say a few things. We're working with the Istio community, and we're basically helping lending this right now to come with a nicer interface for WASM in Istio. What I will say is that Glue Mesh is already out of the box working with this. What we did, we used and leveraged the Envoy filter. And basically that way you can distribute it, WASM filter, you can build it, you can distribute it, WASM filter, and you can do all of this out of the box simply. So I think, and we are working together with the open source community to make maybe the interface for the user a little bit better in Istio. But it's doable. It's really doable. Right. That's what I'm trying to say. I'm excited about that.
Yeah, how is governance and future evolution working for Istio? I mean, not only just for the Envoy filter, but for the entire package.
So what we see, I will just say, in our customers, we have a few customers, and there is something called FIPS compliant. So for instance, what we're doing, we have a distro of FIPS compliance that we basically just took Istio and compile it as a FIPS compliance, and our customers running this, the government's customers. Yeah, I don't know. Lin probably has more input.
Yeah. Lin, how's Istio building? What's the committee looking like? Where you're steering it? Is it open for community input? stuff like that?
Oh yeah, are you? So I
Yeah,
wasn't.
I didn't
You were
understand.
asking.
Yeah,
Yeah,
sorry, it's a
you
bad
took
question.
a different direction. Okay. Yeah. So last time we checked, I think it still have like, as far as contribution company, there's like 300, and individual contributor that we checked from last year, there's like 400 plus individual contributors. And
Wow.
by contributors, we mean people submit at least one PR, right? It's not like they open an issue, it's they actually have a merged PR into Istio. The steering committee, we opened up door for steering committee, like Christian from Solo, right? Solo wasn't on the steering committee before, but we opened up the door for Christian from Solo to be on steering. We opened up for the steering committee, really opened up for Salesforce and a couple of other companies like Tetra, Aspen Mesh, and Huawei. So it's definitely a lot more diverse than it used to be, just the founders, which is IBM and Google and Red Hat. So I think that's being perceived a really welcoming changes from the community. We're also we're also working on like the governance model for the technical oversight committee now. So we're trying to ensure, people have a way to move up from worker fleets to be the technical oversight committee as well.
Okay, cool. Well, we're nearing the end here. I thought I'd just open the floor to any last thoughts you'd like to leave listeners with. I know, Lin, like you have so much more to expand on with your Istio Explained book, and we'll be sure to link to that in the show notes. But yeah, anything you'd like to leave viewers with on this introduction to Service Mesh dialogue?
Yes. So definitely, I want to give a plug to IstioCon. I believe it's currently scheduled on the 3rd week of February. So we're going to have a really exciting schedule out for you. So the schedule is going to be out next Monday on the January 25th. The attendance is free, so go ahead, register and grab your tickets. So if you search IstioCon, you'll probably find it on the first Google search result.
All right, fantastic. IstioCon in February.
Yep.
Great.
All right, great. Yeah, Idit, any final ideas?
Yeah, no, I think that all those years, what we all was talking about Service Mesh, but in the nutshells, there was mainly talking, a lot of marketing out there. I'm not talking specific about Istio actually doing, I'm talking about the rest of the Service Mesh ecosystem in generally. There was a lot of announcement. I think that what we see right now is that, at least Istio definitely, but you see on customers, people are trying to actually implement it, actually running it in production, actually make it more robust. And I'm very excited about it, because as much as more people will use it, that's more use cases, that's more interesting stuff that we can do. So I'm specifically extremely excited about it. And yeah, it will be an interesting year for sure.
Yeah,
Excellent.
Same as me. We're going to try to put a lot of talks on how customer using Istio at IstioCon. So
yeah.
Fantastic. Yeah, well, good luck to you, and we'll see how the whole space matures. It's a really exciting time for this tech.
Thank you so much.
Awesome.
Thanks so much for
being
having us.
Yeah, of course. I'm just going to end with some slides here, but yeah, feel free to sign off or whatnot. This has been a presentation from Nordic APIs, and just to leave you with a few updates from what we've been up to. Essentially, if you love APIs and you want to contribute your thoughts, our blog is open for submissions. You can reach out to us at nordicapis.com/create-with-us, or follow us at Nordic APIs on Twitter. We also operate a newsletter featuring bi-weekly updates from our writing team, and we're covering many pressing areas in the microservices, service mesh, API space, and other areas that are related. So you can sign up on the website to always have a little bit of dash of API knowledge in your box. And until it's safe to hold our physical, typical in-person events, we'll just be arranging these monthly webinar livecasts. So if you have something interesting to share, feel free to submit a talk, and we'll consider you as a speaker for an upcoming livecast. And finally, as usual, thank you to our sponsor, Curity. You can learn about their OAuth server and identity-driven API security solutions at curity.io. So that's it for now. Thanks for watching. And thank you so much to our speakers, and thanks to everyone who tuned in live and helped generate some quality discussions. Hope to see you at our next LiveCast. Bye now.